Okay, we're going to do section 4.1, and this deals with solving quadratics using the square root property. Again, quadratics have square terms in them. So here's some example of quadratics. Here's the full kind of the standard quadratic. It has a square term, an x term, and a constant. Here's another version where you have just the square term and the x term, but no constant. And then it could be just the squared term and a constant, but no x term, a missing linear b term. So what we're going to focus on here is using the square root property, okay, which is going to focus on a situation like the third, where we have a squared term, but no x term. And the previous unit, we were solving quadratics. And if you remember, if we had a quadratic equation and we isolated the quadratic, or excuse me, I'm sorry, not the quadratic, but the radical. So we're solving radical equations. We'd isolate the radical, and to get rid of say, a square root, what did we do? We would square it. Of course, we had to do it on both sides. And what was the result of that? You would end up with x is equal to a 9. Well, here with quadratics, using this quadratic square root property, we're going to isolate the term that's squared on one side and the number on the other. And then just like we would square a square root to get rid of the radical, here to get rid of the squared term, we're going to do the opposite. We're going to take the square root in the course of both sides. And when you do that, out comes the x from the left. And when you take the square root, what you have to remember, it's going to be a plus and a minus, whatever the square root is. Okay, so it's exactly the same as we did with radical equations. We're going to isolate the square term. So here it is, number 2. We want to isolate the square term, get it by itself, and then we apply the square root property. We take the square roots of both sides. That'll give us the x that was being squared, and then the right side will be plus or minus the square root of whatever the constant is. And then whatever results, we go ahead and solve it for x to find the solutions. And there's really not going to be any serious domain restrictions, at least on the ones that we do. So let's look at some examples. Okay, so the first thing you want to do, just like with a radical equation, is we want to isolate, in this case, the squared term by itself. So we would add 180 to both sides, giving us this, okay? And then what do we do? Well, to get rid of the square term, we would take the square root of both sides. So this would result in the square root of h squared is h, and the square root of 180, it's going to be 6 square root of 5. Now, this is from last chapter, but just for the sake of review, let me go ahead and show you that if you're not sure how to break that down, you can always, oh, I lost something. Let me pull this back. Let me redo that. Okay, so here's 180, and we break it down into prime factors. We can see that we have 2 3s, so that means a 3 came out. We have 2 2s, that means a 2 came out. Well, 3 times 2 is 6, so that's where the 6 came from. And then we have the 1 5 left over, so it remains underneath. And so h would be plus and minus, or minus 6 square root of 5. So there's actually 2 solutions. Okay, so very simple. This is really very, very simple. So this other example here, the only thing we need to do to isolate h squared is divide both sides by 3. So if we do that, we end up with h squared is equal to 36. Take the square root of both sides, and we end up with plus or minus 6. Okay, here you may go, well, there's an x term here. But in this particular case, the x term is going to drop out when we distribute the 1, which doesn't change anything. We're going to end up with x squared is equal to 4x, plus 4x is equal to 25 plus 4x. And then when I isolate the x squared term and I subtract 4x, the x terms cancel out, leaving me just 25. And so then you just take the square root of both sides, and you get plus or minus 5. Now remember, if you have a fraction, so I add 256 to both sides, and then I divide by 144. And these look like nines on this, but these are actually fours. When I take the square root of both sides, instead of taking the square root of all of this, one way to look at it is you take the square root of all of it, but it's better to break it into using the quotient property of taking the square root of the top, the numerator, and taking the square root of the denominator. And when I do that, um, I'll end up with r, the square root of r squared is r, and then square root of 256 is 16, 144 is 12, and that reduces down to a plus or minus 4/3. Okay, so I think you'll find that this is pretty simple. There's really not much else to say. Yeah, a slight variation to this is where we have an equation where it's quadratic in form. Okay, but what do we mean by in form? Well, here the x is not by itself, but you have an x minus an h or an x plus h, where h is some value, and that quantity is squared. So if you have this situation where you have an x plus or minus some value squared, then treat it as a square, because it is. And you want to isolate it, get the number to the other side, and then apply the square root property. Okay, when you do that, the x minus h will come out from the square term, and then it'll be plus or minus the square root of k. Okay, so you can see as on this example, this is already in that form. Since it's quadratic in form, I take the square roots of both sides. So the square root of x minus 3 squared gives me x minus 3. The square root of 16 is plus or minus 4. So here I have removed the square term, and I do have plus or minus 4 after taking the square root of the right. And so what do? There's going to be two solutions here. If I add 3 to this side, by adding 3 to both sides, I'm going to end up with x is equal to a positive 3 and then plus or minus the 4. So there's two solutions here. There's a 3 plus 4 and a 3 minus 4. The 3 plus 4 adds up to 7, so that's one solution. And then the 3 minus 4 adds up to -1. That is the other solution. So you can see that here there are two solutions. Okay. And so if it's quadratic in form, let's take a look at this. Well, this one, there's nothing I need to do because it already has the square term by itself and the 32. And so I take the square roots of both sides. And when I do that, I'm going to, here it is here. Now you got to remember how to simplify a radical, right? And so 32 does have a perfect square in it of 16. So I'm demonstrating here the 16 is 32 is really 16 times 2. And if I apply the square root of 16, the 4 comes out in front. So I'm going to end up with p plus 8 is equal to plus or minus 4 square roots of 2. That's the simplification of the square root of 32. And then when I subtract 8, it's going to be minus 8 plus 4 square root of 2 and minus 8 minus 4 square roots of 2. Okay, so here's the two solutions. If the software allows it, and every problem it could be different, but it's perfectly fine if you have the choice to do the -8 and click the plus minus if it has it, and then do your 4 square root of 2. This represents two solutions because of the plus minus. If you have to do them distinctly, then you break up the plus and minus into two answers. Okay, so the only thing to do on this problem here with the 8 is divide both sides by 8. And when you do that, you're going to end up with 16. And then we're right back where we started. Take the square roots of both sides. That leaves us with x minus 2 is equal to plus or minus 4. And at that point, you add 2 to both sides. And so 2 plus 4 is equal to 6. And then the 2 minus 4, using the plus minus, is equal to a -2. So there are the two solutions. Okay. Just a little bit more complicated, but not much. If you have to get rid of the 3 and the -6 to isolate the square term, I would add 6 first. That gives me the 147 on the right. Divide both sides by 3, and that would give me 49 on the right. Then take the square root of both sides. And when I do that, I get x plus 5 is equal to the square root of 49 plus or minus. Subtract 5 from both sides. Whoops, let me go back. And it'll be minus 5 plus 7, which is 2, and minus 5 minus 7, using that plus minus, is equal to a negative 12. Okay, so quadratic in form is no different. You just isolate that thing that's quadratic and then take the square roots of both sides. I'm going to show you the solutions to some of these word problems. Um, Now this is function notation, right? So this is represents your height as a function of time. The t represents time. And so in this problem, they tell us that they're asking the question, when will the ball, how many seconds will the ball be at 36 feet if you drop it off a 100-foot building? Okay, so 36 is the height we're interested in. So we're going to replace h of t with the height that we're interested in. Okay, so that gets replaced with 36, and now we're solving for time. At what time does it hit 36 feet? Well, this becomes a very simple quadratic equation to solve using the square root property. Subtract 100 from both sides gives me negative 64. That's a 4 on the right. Minus 16t. Divide both sides by negative 16 gives me t squared is equal to a 4. Take the square roots of both sides gives me t is equal to plus or minus 2. But this represents time. So in the context of this problem, you can't have negative time. So the only answer that will make any sense is a positive 2. It will take 2 seconds for that ball to reach a height of 36 feet when dropped from 100. Area problem, the area of a square garden. Well, the formula for the area of a square is just s squared. Remember that a square has equal sides. So this isn't a great picture, but each side is s, exactly the same, and area is length times width. Well, the length and the width are exactly the same. S times S is S squared. So 196, I replace that for area. And then this is just a very simple quadratic. Take the square root of both sides. 196 is a perfect square of 14. I only use the positive because, of course, length can only be positive. Last example, word problem. Diver jumps off a platform from 25 meters. So this 25 represents that initial height. And then how long does it take for the diver to reach a height of 5 meters? Here's the 5 meters right here. And then use your calculator to answer to the nearest hundredth of a second. So we won't leave this in radical form. We'll go ahead and take this all the way down to an actual number. Well, here, if I want to isolate the square term, the first thing I would have done was subtract 25 from both sides. That gave me this negative 20. Then I would divide both sides by a negative 4.9. That gives me this. Take the square root of both sides. I'm only going to use the positive root because time cannot be negative. And if I round it to the nearest hundredth, it'll be 2.02 seconds. Okay, so that's it for 4.1. It's really pretty basic.